Hi, in this lesson, we're going to dive deeper into different types of algorithms and discuss how to choose the cleanest, most efficient way to solve a problem. We learned earlier in the course that an algorithm is simply a set of step-by-step instructions. So if the set of instructions answers the problem, such as how to get to the movie theater, how could one set of instructions be better than the other? In this example of an algorithm, the path that the green car has to take is very clear. The program is two simple steps. Make a right at the second street, and take that street until you reach the far end of the park. What if we were given these instructions instead? We would still arrive at our destination, but this algorithm is unnecessarily long. It's not the most efficient path from the starting point to the ending point. Simply having the shortest algorithm is not always the answer either. This algorithm is shorter than our first one, but it's not as clear. The first algorithm we saw was easier to understand. There are many different ways to solve a problem. The two aspects that help when comparing algorithms are efficiency and clarity. Efficiency is taking a look at how fast the algorithm is, and then clarity is dependent on how clear and readable the algorithm is. These are both important when writing algorithms. Let's compare a few algorithms. Take a look at both of these algorithms written in pseudocode. Which is the better algorithm? This first algorithm is more efficient. Even though both of these will turn a person to the right, the second one will take longer to do it and might make you dizzy. How about this one? Which one's better? The second algorithm has better readability. Can you imagine what the first algorithm would look like if we were changing colors 20 times? As our programs get more complicated, it's important to brainstorm and develop the proper algorithm before diving into the actual coding of the program. Creating the best algorithm for the task makes the programming part run much more smoothly and makes for a better program. Algorithms consist of three basic building blocks: sequencing, iteration, and selection. You have already used all three of these in your programs. Sequencing is a step-by-step execution of instructions in the order that they're given. Sequencing is a set of precise steps. In this pseudocode function, the program would run through each step in the order that they're listed. Doing so will create a bridge and complete the function. Iteration is a repetition of instructions a specified number of times or until a condition is met. Iteration repeats part of the code as necessary. In this example, the code will loop or iterate 10 times to effectively create a countdown from 10 to 0. Here's another example of iteration. A while loop will also repeat code, or iterate, a specific amount of times or indefinitely. In this example, the loop will repeat until timer is no longer less than 3. Selection is when we use a condition to determine which part of the algorithm is executed. Selection uses conditional statements to determine an output. In this example, if the time equals 0, then the stoplight will turn red. In summary, all algorithms are made with a mixture of sequencing, iteration, and selection. Sequencing is the step-by-step execution that follows a natural program flow. Iteration is when commands are repeated using for loops or while loops. And then selection is when a choice is made by the program that is dependent on conditions within an if or if-else statement. All right, let's take a look at some algorithms in this lesson.